The study which I present is an integral part of a project funded by the University of Korca, using a comprehensive assessment of digital skills in my university. And this was conceptualized as a complementary project of a more broader project to address digital transformations in Western Balkan countries. So the title is Shaping Future Learning Through Digital Skills Profiling. This study is focused more on some methodological issues, and the language is somewhat technical, but I try to make the language more accessible for the audience. However, if anyone is interested to some technical details, I will be very happy to address your questions after finish my presentation. This is the structure of the presentation. In the contemporary higher education, a growing mismatch exists between the levels of digital skills and the levels required by the labor market. While labor market demands are continuously increasing, students demonstrate substantial heterogeneity in their skills. However, educational institutions often respond with uniform curricula that assume similar skill levels across all students. This misalignment between diverse student abilities and standardized curricular approaches contributes to system underperformance. And the one-size-fits-all curricula limit the effectiveness of educational provision. The study highlights the importance of grounding curricular development in a clear understanding of students' digital competence. Digital skills are important for employability and for long-term resilience, yet students differ significantly in their educational background, learning trajectories, prior experiences, and this difference shape how they engage with digital learning and how effectively they develop more advanced skills. Rather than assuming a homogeneous student group, the study emphasizes the need to recognize this variability and to model it systematically. By using evidence-based information, the study aims to support a more targeted and personalized curricular development in response to diverse student needs. The study, based on some methodological recommendations, examines how combining some variable and person-centered approaches can more effectively address the heterogeneity in students' digital skills. More concretely, comparing 3 different approaches of latent profile analysis by using 3 different types of indicators, the study examines if the model whose indicators more accurately explain the nature of digital skills more effectively address this heterogeneity. Why this study is important? Because a growing body of research, as well as consecutive reports from some important international organizations such as OECD or European Commission has documented the gap that exists between digital skills levels that students possess and those required by the labor market. These organizations underscore the urgency of moving beyond experimental approaches because there is no time, there is no room for other experiments. There is a strong need to develop more advanced assessment tools which more accurately can address these issues. Digital competence is not limited only to technical skills. It includes evaluative, cognitive, communicative skills, strategic skills, all important for normal functioning in the future society. The digital competence frameworks for citizens developed by Frashëri on 2013 with its subsequent updates reflects this complexity by defining digital skills as a combination of a general proficiency and domain-specific factors which can interact and reinforce each other. This means that digital skills have a multidimensional and hierarchical construct. There is a general factor which measures the quantitative part of the level effect of the construct or phenomenon, and some different patterns of strength and weakness which measure the qualitative part or the shape effect or the dimension. Therefore, meaningful profiling requires us not to capture not only how competent students are, but how their competence is configured across different skill areas. By doing so, this can support the development of curricula in a more targeted and personalized manner, in a line with. Here, I have headed a schematic configuration following a somewhat retrospective logical flow to make more easier what I'll explain next. Evidence-based design is essential for digital education. In this context, evidence-based curricular interventions are of high importance. The study highlights an integrated approach, which is person and variable-centered approach. Person-centered approaches are these techniques which classify individuals, in our case students, in different classes, relatively homogeneous classes who share common characteristics, common configurations of digital skills, while variable-centered approaches are these techniques who classify variables into meaningful factors who better explain the relevant psychometric multidimensionality of a phenomenon. So, this approach can support a targeted and personalized digital skills integration to address students' heterogeneity in digital skills. And in this context, late profile analysis is an optimal approach who can address the hidden heterogeneity in students, classifying students in relatively homogeneous groups which share common characteristics for different skill configurations. The extracted latent profiles derived from this analysis is highly dependent on the quality of indicators on which this analysis is based. And here we must consider some important recommendations from key scholars in the field, such as Herbert Marsh or Alexander Morin, the most important researchers during the 2 or 3 decades. These researchers had noted that in order that these latent profiles to be highly informative, this should be differentiated based on shape effects or on qualitative information. But these shape effects, this qualitative information should be clearly separated from the quantitative information. So it is important that this analysis should be based on rigorous measurement of digital skills. In this context, bifactor structural equation model is the only approach which explicitly can share the shape effects from the level effects. Some other approaches are, for example, confirmatory factor analysis, are not able to explicitly shape from level effects due to its restrictive pattern of independent cluster modeling, which can result in inflated factor correlations and even in the distortion of the latent structure. So here in this diagram, these are the main 4 approaches who model complex structures of digital skills. In my study, I compare 3 approaches. This is the second approach, the first diagram, where the factors derived from different groups of indicators contain shape and level effects, but not clearly separated. And in this case, the informative value of shape effects is obscured or overshadowed by the uncontrolled dominant level effect. Only factor score derived from the 4th model, the bifactor SM, can separate clearly shape from level effects through some modifications in the Schmid-Lyman algorithm and using the orthogonal target rotation. So, in the first approach, where indicators were expressed as aggregated scale scores, the profiles were differed only based on quantitative effects, resulting in a minimal or negligible informative value for the curricula. In the second approach, where the indicators were expressed as factor score derived from confirmatory factor analysis, we are not enabled to separate global effect from domain-specific effects, shape from level effects. So the informative value was also minimal, slightly better from the first approach, while in the third approach, where indicators were expressed as factor score derived from the BSM model, the profiles, which were different configurations of global and domain-specific effects, was highly informative. So, if we turn this configuration, we see that indicators derived from factor scores of BSM model can serve as input to support the latent profile analysis in the more optimal way, supporting optimally the curriculum development through this approach. The study was based on data gathered by an online survey disseminated via Google Forms with students of my university. Around 600 students completed the questionnaire. The methodological design was structured in such a way to support stable and reliable latent profiles, considering sample size requirements, psychometric characteristics of measurement instrument, the software package used, the approaches, the estimators, and in which approach 2 to 7 class models were compared. In the first approach, the model with 3 classes resulted as the best solution, characterizing or differentiating students from one class to other only quantitatively, so resulting in very low or informative value to support curricular development. In the second approach, the 5-class model resulted as the best model, indicating a slight improvement, while the third approach, based on BSM factor scores, was resulted highly informative. The different configurations between global and domain-specific skills resulted much more informative to support an effective integration of digital skills elements into curricula in a more targeted and personalized manner. As we can see in the third section of this table, which is the better approach, domain-specific elements, which are related with operational and communicative skills, when not accompanied by strategic and creative skills, are associated only with low levels of digital skills. While, as we can see in the fourth class, where the content creation and production component has resulted marginally significant, the combination of strategic and creative elements, despite the behavior of other components, is highly associated with general skill elements. This is highly important to inform the curriculum development. 3 key insights of this study: digital competence, heterogeneity, is not random, he is systematic. We obtained different meaningful groups. The information value of latent profiles, to support curricular development is highly conditioned by the approach we selected, and latent profile analysis based on factor scores derived from BSM models preserve digital skills, multidimensionality, and hierarchy. This study, or result of this study, are important for personalized learning, adaptive curricula, and efficient resource allocations because we saw the importance of creative and strategic skills, and some institutions, especially those with under-resourced institutions, such as my institution, can effectively allocate resources, prioritizing these components which are most significantly associated with digital skills, such as creative and strategic skills. And the main result is that this integrated approach can effectively support a more targeted and personalized integration of digital skills elements into curricula in line with diverse students' needs.
Thank you. Thank you so much for your